And let's pick up where we left off. We are in Bootcamp 1, Module 2, Managing Data. And we've talked about reading in data, we've talked about writing data. Let's talk about working with data, managing data. There's a lot we can do, obviously, in R with transforming data, finding typos, finding errors, fixing errors, doing transformations of all sorts, mathematical operations. We're going to start off with talking about querying data, and we're going to start off with Boolean operations. Boolean operations just mean we're going to ask a question, and the question either has a true or a false outcome. And so we're going to ask questions about our data specifically, and R is going to tell us either is it true? Is that condition true, or is the condition false? That's a Boolean operation. That'll become clearer as we start to actually work with it. Let's move into RStudio. So let's again go back to our RStudio project. There we go. There it is. And we're going to pick up where we left off. Here is the section that starts with these Boolean operations. Let's first do a quick clarification here. We already know this assignment operator, right? Looks like an arrow. That's what we've been using to assign an object to a value of some sort. We can also use the equal sign to do assignments. So if we could say A is assign the value 3, and it'll appear in our global environment as A, and if you just type out A and do Control Enter, you get the value 3. So that's great. You could do the same thing with the equal sign. There we go. But here's a common rookie mistake, is that this double equal sign is a question we're asking. It's a Boolean operation. We're asking a question. Essentially, the question could be phrased as, is A equal to 3? Answer's either true or false. So R is going to give us either true or false. So is A equal to 3? True. It is equal to 3. Is A equal to 2? Yes, it is equal to 2. So that's the Boolean operation, double equal sign. If you did an equal sign, you're going to assign the value. You're going to assign A the value 2. That may not be what you wanted to do, but you've now overwritten whatever was in A already. So just be careful when you're asking a question that has a true or false. You use the double equal sign to ask, is something equal to something else? All right, so that's one Boolean operator, is the double equal sign. Now we know. Let's go through some of the other basic Boolean operators. You have the less than, you have greater than, less than or equal to, greater than or equal to, which is the one we've already seen, double equals. Not equal to uses the exclamation point to negate the equals. So exclamation point followed by an equal sign can be phrased as not equal to. And then this special operator, percent in percent, which means does an object match with any one of a set of other values in a different vector? And we'll get to that. Don't worry if you don't understand that right away, but we have an example with that. So does this match with any one of a specified group of other possibilities? Let's play around with Boolean operators for a second. So we have seen the double equal sign, right? Let's try a couple other things. Is A less than 5? Yes, A is less than 5, because A is now, at least in my working directory here, in my global environment here, that A is equal to 2. Is A greater than or equal to 2? Or sorry, less than or equal to 2? Yes. Is it less than or equal to 1? No. So it's a good idea just to play around with some of these things just to get familiar, because these come up all the time. What's another one we can work with? Not equal to. Is A not equal to 2? It is not equal to 2 because it is equal to 2. So is it not equal to 3? True. Another way to do this would be to move the negation operator out here, but then you have to change this to a double equals. So basically what we're saying is A equal to 3? And then reverse that. So if this is true, whatever that is going to be reversed if you put the exclamation point, because the exclamation point basically reverses any Boolean outcome. So just to convince yourself that that is in fact what happens with the exclamation point, you could write out exclamation point true, or, and that gives false, or exclamation point capital T, and that provides false. So that's just playing around with some Boolean operators. We'll wait to play around with the % in % until a little bit later. But let's do some more tests. Before we do that, you can combine multiple Boolean operations using the AND operator. So you can ask multiple questions at the same time. Is this less than this, or greater than this other values, or something like that. You can combine multiple questions into a single query using the ampersand operator or the pipe operator, which means or, can be interpreted as or. So we'll see some examples of that as well. Let's run through some examples. We're going to assign the object y to the value 4. We'll assign another object z that holds the value 6. And then we can ask some questions. So is y equal to z? That's what we're doing here. Y double equal sign z. Is y equal to z? It is not, so it returns false. Is y less than z? Yes. Is y not less than z? False. So we just reversed that Boolean query using the exclamation point. Okay, so now let's get back to our data. So since I started a new session, I have to read back in the data we originally read in the previous video. So let's just do that. So we'll go back up to the top and find this data.df. We'll read in that CSV file, data.csv, and so now I have the data again. So now I can work with it. So if I don't think you probably have to do that, but that's what I had to do. And let's look at this. Okay. So data.df, we use the bracket to subset. So we're just going to pull out everything before the comma here is the rows where, since it's blank, we're going to use all the rows, but we'll only use the second column. So if we just looked at this, that's going to be the second column of data.df, which, as we recall, is the import column. So we're going to take the import column and we're going to ask the question for each of these values, 46, 74, 89, so on and so forth. We're going to ask, is it equal to 74? Now we see there's a couple 74s here, right? 1 and 2. So let's ask the question of the data set, are each of these values equal to 74? So we'll get a vector of trues and falses, right? And it should be false, true, false, 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 etc., and then true out here as well. All right, so let's run that line. Data.df, take the second column, and we ask, wait, what happened? it didn't return anything. Can you figure out what went wrong? We didn't get a vector of trues and falses. What did we do wrong? We didn't use the double equal sign. Because we didn't use the double equal sign, we actually assigned the value 74 to all the rows for the second column of our data. So if we look at our data now, that entire second column is equal to 74. So we overwrote our data, and we probably didn't want to do that. We know we didn't want to do that. We wanted to ask a Boolean query, and we screwed up. So what we have to do is go in and read the data again, because we clearly screwed up. So let's start over, read the data again, and do it right. We do the double equal sign and ask the question, for every element of that vector, is it equal to 74? And we get the right answer, false, true, false, etc., etc. There's 2 instances where it is equal to 74, and those evaluate to true, so that's good. So now let's get back to working with, or do some additional operations with data. The which function is a really useful function for pairing with Boolean queries, because what it does is it takes a Boolean query, it takes a vector of trues and falses essentially, and it tells you which of those elements, which indices are true. So in this case, we have a vector of trues and falses, but we have 2 trues. One is the second element, that's the index is equal to 2, so that's index 2, and then we have another true out here, which is index 14, 15, 16, 17. So we have 2 and 17 are the indices of the vector elements that evaluated to true. That is, they're equal to 74 in this case. So if we use the which function and put this query in there, which is going to return a vector of trues and falses, we should get 2 and 17, and we do. All right. So the which function is actually really useful. So here's a couple examples. So just what we just did. What about if we want to return the elements that evaluate to false? That is, those elements of that import column that are not equal to 74. Well, there's a lot more of those, and we can do it that way. And we can determine the elements of the import column that are less than 74 if we want. So again, we can run a lot of queries this way. What about the OR operator? We can chain a bunch of queries together and say, okay, which elements of the import vector are either, because we're using the OR operator here, which are either less than 74 or equal to 91. So let's look at that. So we have a bunch of elements that actually return true there, and so they meet either one of those 2 conditions, either being less than 74 or equal to 91. What's cool about this is that what we can do is subset the data based on a query that we want to run. So here's an example of that. So we take our data.df, which this is what it looks like in full, and we take only those rows, because here we're specifying the rows that we want to return, because it's before that comma. So here are the rows that we want, and we want column 2. So the rows we want are actually determined on the basis of a Boolean query. So we're going to take only those rows where that second column is less than 74. The import value is less than 74. We know the results of that. It's just a vector of indices. Oops, I didn't include that final parenthesis. Let me do that again. So those are the indices that we want to return. Those are the rows, essentially, of the data frame that we want to keep in this case. And let's run this line. And it gives us the values of the import data, the import column that meet that criterion. Now, if we wanted to return all the columns that meet that criterion, we can get rid of that 2 there, and now we get a whole data frame back. But it's only those rows that meet the criterion that the import column is less than 74. All right? So we can use these Boolean queries to find subsets of data that are of particular interest to us, and we can then do things with those data. We could save this data frame as another object. So data.df subset, I could make a new object, and now that object is just those rows that meet the condition that we're interested in. Another thing we could do, if we want to, is save the indices that we want to store in a separate line. So if we run this line, we then have an object called indices, which just stores a vector of indices that we might want to use later. And then we can use that vector within the next line of code to specify which rows we want to keep. And we can use it that way. So just like any programming language, R is very flexible. There's a million ways to do the same thing, and it can be useful to know some of that redundancy, because then you never get stuck anywhere. You always know some way to do what you want to do. You don't have to use the which function when you're using Boolean logic to subset a data frame, because R automatically knows that if you give a vector of trues and falses as the indices when you're subsetting a data frame, so you'd use that bracket, and then you provide the indices for the rows, the indices for the columns after the comma. If you provide a vector of trues and falses in place of numbers in your indices, R automatically knows just to keep the trues. And so it actually will do the same thing here. If you just say data.df bracket, give it the query results, which is just a vector of trues and falses, true if the this column is less than 74, false otherwise, it'll keep only the trues, and it will give you that answer. And if you want to get the whole data frame, all the rows, this will do that. Just omit the column index. All right. Now let's do a little more complex query. First, let's make a list of countries that we're interested in. We're interested in this case in Chile, Colombia, and Mexico. So this is just a vector of strings with 3 countries. Now, this country column in our data set, is just a bunch of text strings with different country names. So we can do a standard query with text strings and just say, okay, I want to know which row is the country equal to Chile, which row represents Chile, basically. And it's number 3, right? So let's look at data.df so we can verify that. Bolivia, Brazil, Chile. So Chile is the 3rd row, and so this query here just gives us or returns the index that is Chile. We could also do the very same thing by taking this vector of countries and asking, is it, for each of these elements, is it equal to Chile? Well, it's going to be false, false, true, false, 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 etc., etc. Let's look at that. So again, a vector of trues and falses. If we use the which function, it'll just give us the index that is true, and that should be 3. So, whoops. There we go. So again, lots of different ways to do things. Now let's try something else. Let's ask, I want to know which of these countries, or which of this vector of countries are at least one of those countries, are Chile, Colombia, and Mexico. I want to do all at once. I just want to say, okay, is this Chile, Colombia, or Mexico? Well, no, it's not. Is this Chile, Colombia, or Mexico? No. Is this Chile, Colombia, or Mexico? Yes, it is. But so is this, right? And so I want to do all those queries all at once. And it seems like this might work, right? You just use the double equal sign, but instead of a single country, give it a bunch of countries here. So we can ask, is this equal to any one of these countries? Well, what happens if we do that? R doesn't like that. So that's actually not the right way to ask that question. This is where that percent in percent Boolean operator comes in. So instead of using the double equal sign, we use percent in percent to ask the question, for each one of these countries, is it any one of this list of countries? And we can say, well, this is false, this is true, because it is part of this list of countries, right? And so we can just go element by element and just ask that question. Each one returns a true or false, and we'll get a vector of trues and falses. But now we're asking this more complex query about whether each element belongs to a list of potential elements. So there we go. And we can figure out, since we use the which function, we're returning the indices that represent either Chile, Colombia, or Mexico. And that's 3, 4, and 14 right here. We can combine operators again and say, we're going to ask, okay, which of these rows are actually in that list of subcountries that we're interested in, and the fourth column is equal to n. So that returns 2. So there's 2 of those countries that also have that fourth column equal to n. Honestly, I can't remember what that fourth column is represents, but that's not important for this particular lesson. And we can do another one where, well, this is the same query because the fourth column is product. So this is just another way of doing the same thing, again illustrating redundancy. And again, if we want to specify a set of indices in advance that we're interested in, we can then use those indices within this bracket notation to subset a data frame. We'll retrieve all the columns just by leaving the column blank, and we'll just retrieve the indices we're interested in as the rows, and we can subset a data frame like that. All right, next I'm going to ask you to download a new data set and get some practice with subsetting data using Boolean operations. This data set is data on a turtle population, and you can get this data from the website. Just go to where it says practice exercise, and you'll see that there is a link for this turtle data. So just remember to save it into your project directory. All right, and I need to navigate to my project directory, and there we go. So read this data in and try to follow along on the website, and I will, in the next video, walk through this practice exercise and then illustrate some additional things we can do with data, and then we will set you off on your own to do the challenge problems at the end.